Hello, everyone. Let us talk about a problem from CMI 2016. Now, this is not a very hard problem, but it requires very high fundamentals in algebra beyond your school syllabus. So, we are going to look at this problem and learn the techniques required to solve these kind of problems. Now, we are given cos square of pi by 101 and cos square of 2 pi by 101, and it goes up to cos square of 100 pi by 101. We're required to evaluate this sum. First of all, what we can do here is this. Whenever you see an expression like this, you have to remember about the roots of unity. So start with x to the power n equals to 1 for a positive integer n. It is known that the solutions to these equations are of the form 1, comma, e to the power 2 pi I by n, e to the power 2 pi I multiplied by 2 by n, and this goes up to e to the power 2 pi I multiplied by n minus 1 by n. And the first term can simply be considered as 2 pi I by n multiplied by 0. So you would see there are a total of n roots as expected. These are called the roots of unity. Now, why is this important for this problem? Using Vieta's relations, you can understand that the sum of the roots of this particular polynomial equation is 0. So the sum of the roots of this must be 0 as well, which means that we must have e1 plus e to the power 2 pi I by n plus e to the power 2 pi I multiplied by 2 by n and all the way up to e to the power 2 pi I multiplied by n minus 1 by n. All of these terms add up to 0. Now, the next crucial thing to understand is that we should know that e to the power I theta is equal to cos theta plus I sin theta. As I said, it goes beyond the school syllabus or what is taught in grades up to 12th because these things are not part of the syllabus, but somehow these mathematical tools help you very much, and even understanding the proofs and how where they came from helps you a lot in understanding these sums and applying these over and over in different sums. So, using this, we can write the above equation as follows. The real part, because all of the e powers, as you can see, are in the form of e to the power I theta. So, all of these will give a cos theta, each of the terms, and all the terms will also give a I sin theta term. So first you group the real part, that is all the cos thetas and 1 together. You simply write cos of 2 pi by n. So now I have written all the terms here, and hopefully now we can understand why this is important, because since the right hand side is 0 and the left hand side is obviously a complex number, using equality of complex numbers, you should always know that the real parts of both sides will be equal and the imaginary part of both sides would be equal. In this case, it is 0. Obviously, the real is 0, the real part is 0, the imaginary part is 0, and therefore we can conclude we only need the real part for this problem. Therefore, the real part here would be simply equals to cos of 2 pi by n, and you can add it all the way up to the last term, which is cos of 2 pi multiplied by n minus 1 by n, and this should be equals to minus 1 because we had a plus 1 here. I'm just sending it to the right hand side. Now you apply the trigonometric formula, which is cos square theta is nothing but 1 plus cos 2 theta by 2, or equivalently you could say that cos 2 theta is equals to 2 cos square theta minus 1. Apply this, and these terms, cos 2 pi by n, all of these can be written as cos 2 theta, right? Therefore, applying, you get in each bracket 2 cos square of pi by n minus 1 for the first one. For the second one, which was cos of 4 pi by n, you would simply get 2 cos square of 2 pi by n minus 1. And the last term, you should get 2 cos square of pi times n minus 1 by n equals to minus 1 equals to minus 1. Now, how many terms are there? There are n terms here, right? So this would simply mean that you start from 1 and you end at n minus 1. So only n minus 1 minus 1s are there. So you can take all the 2 common and you can write this as 2 cos square, 2 times cos square of pi by n plus cos square of 2 pi by n. And the last term here would be cos square of pi times n minus 1 by n. How many minuses are there? Minus 1s are there. There are n minus 1 terms. So minus of n minus 1, and you have a minus 1 here. Simplify this and you should get cos square of pi by n all the way up to cos square of pi times n minus 1, 1 second, n minus 1 upon n equals to, you take this to that side and it becomes n minus 2, divide by 2, you get n minus 2 by 2. Put n equals to 101 to get our desired result, and that would give us cos square of pi by 101 plus cos square of 2 pi by 101, and you add all of these to get cos square of 100 pi by 101 equals to, n was 101, so we on the right hand side we should get 99 by 2. This is the correct answer. So what we have learned in this video, we learned about the roots of unity and how to use them. We learned about the equation x to the power n equals to 1 and its solutions. In very brief, we learned that Euler's formula e to the power I theta is cos theta plus I sin theta, and we did some basic algebraic manipulations. So this is kind of a problem which everyone who is appearing for these kind of exams, or everyone who is at a school level or is just plainly interested in maths, should know. So I hope you like this video, and if you are new to the channel, do subscribe and let me know if you have any requests for any kind of problems or theory or anything else. Thank you.